Okay, so continuing with 4.1, here's part 2, a transformation. A transformation is basically a change. Even more specifically, it's a function that either moves or changes an object. That object, whether it's a point, it could be a segment, it could also be a polygon. That's what's called the pre-image. That's basically what you start with, but moves or changes an object to produce a new image. Or a new figure, and then that's called the image. So the different types of transformations, as I mentioned in part 1, like a translation, that's what we'll concentrate on 4.1, but there's also rotations, reflections, and dilations. So again, one specific type of transformation is a translation. A translation, it could also be called a glide. That's like what I call the slang term. The correct mathematical or geometric term is a translation, but a translation is a transformation. So it's definitely a change that moves every point of the object a fixed amount. So let's just say we have a point A, and the coordinates of point A, 3, -5. Okay. And I want to use a translation. One way that you could be given a translation is in what's called vector form. So we just talked about vectors. If this is vector form, notice again, if I didn't use a piece of graph paper, you wouldn't be able to figure out the exact magnitude or the direction of this vector. But this is vector form. And by what we went over for the basics of vectors, you should be able to change that to component form, because sometimes you might be given the component form of a translation. The component form here would be, again, used like the brackets instead of the parentheses here. The horizontal component is 3. That's right here. The vertical component is 1. That's component form. Or the last way is what's called ordered pair notation. So you start with a point, or it could also be, as I mentioned, a segment. It could also be a polygon, but this gives you a rule on how to move or translate every single point. You start with the pre-image, XY, and then there's some sort of transformation, in this case, a translation. So there's an arrow there to X plus, just call it A, Y plus B. So in this case, you start with your point XY, and in this case, the horizontal component is X plus 3. So if I went 3 to the left, this would be -3, and then this would be X minus 3, X plus -3, same thing. And then in this case, Y plus 1. So all 3 of these translations, this is vector form, this is component form, and then this is ordered pair notation. I actually should have kind of circled the whole thing, because if you only write this part, that's not all ordered pair notation. But you can graph this point. I'm just going to give the coordinates of the image. This is the pre-image. So the image are the new coordinates after the translation of point A. To write the coordinates of point A changes from the pre-image to the image. We use what's called prime notation. It's called A prime. That's the transformation or the transformed point, using this little, it's like an apostrophe, except it's not curved, but just a little prime, like a little tick mark. But to come up with the point of A prime, 3 units to the right, 1 unit up. Might be easiest to take a look at this if you're not going to graph your transformation and your translation in this case. So X plus 3, Y plus 1. 3 plus 3. I'm just not going to write it all out. I think you could see what I'm doing. is 6. And then -5 plus 1 is -4. So those would be the coordinates of A prime. If I graph that in a coordinate plane, I'm going to use a new piece of graph paper in order to show you that. So here I have the point graphed 3, -5. That's in quadrant 4. Here is the translation given to me in what's called vector form. So I could use that vector in order to translate point 3, -5. I can even draw the vector with point A being the initial point. And then here's the terminal point. The horizontal component is still 3. The vertical component is 1. I could have written it in component form, 3, 1. 3 units to the right, 1 unit up. And then if I figure out the coordinates of, this is A prime, so that's a translated point or any type of transformation that we go over, we're going to use prime notation. As you'll see, if I have more than one transformation, I'll need to use double prime notation, sometimes triple prime notation as well. We'll go over that in a little bit. But to figure out the exact coordinates of A, I could just take a look at my graph. 1, 2, 3, 4, 5, 6 is the x coordinate, and then -4 is the y coordinate. And that's what we came up with using ordered pair notation for the translation. Okay, this is using vector notation or component form. Sorry, that looks like a parenthesis here. I'm going to make that a little bit better. That's an example of a translation.